Greetings once again, fellow grade 9s, young physics and life science students. Let's begin our descent into a follow-on unit of chemical reactions, okay, under the main topic title of matter and materials. So what we're going to do is today we have a little incomplete mind map there, which I'm going to map out nicely for us in just a second, of reactions of metals with oxygen. Okay, so just to give you a short little insight, is that oxygen is one of the elements that exists in the air that we breathe, okay, and possibly is the most important one for us. Okay, without oxygen, of course, we no longer function. Okay, oxygen is one of the main elements that our liquid in our bodies transports to the different cells, or gets transported to the different cells in our bodies. Our cells require oxygen, okay? But oxygen is a highly reactive element, and it likes to react with metals and non-metals, but we're first going to look at how it reacts with metals, okay? So there's a few metals that we're going to have a look at. The first one is we're going to have a look of reaction of iron with oxygen. So I'm going to write our first metal down here. Iron as our first metal. We're going to have a look at this one. Then we're going to have a look at magnesium, okay, which is another metal. Okay, and then we're also going to have a look at rust. Okay, now rust is basically also known as corroded iron. Okay, when iron starts to corrode, all right, we call it rust. Okay, or any metal that starts to fall away and lose mass, we say that rust, or because it's oxidizing, of course. But we'll get into that a little bit later. We're also going to have a look at and with rust we're going to have a look at the formation of rust, and then we're going to have a look at the ways that we can prevent rusting. Okay, so as a follow on there, we're going to how we can prevent metals from rusting, and the first one here is obviously we're going to look at how this forms, so the formation. We'll just add those two words in for a bit of clarity. Okay, and then our final one up top here, we're also going to have a look at the general, okay, reaction. Okay, the general reactions of metals with oxygen. Okay, we're gonna end off with that. Okay, so that's the map that we're gonna have a look at. We're first gonna have a look at how iron reacts with oxygen and magnesium as our two, which we'll definitely get through, I think, today, and maybe touch on rust today. Otherwise, we'll just carry on throughout the next week or so with this topic before we move on to non-metals and oxygen reactions as well. Okay, I think we're all cool. All right, so the first thing, maybe just to introduce, maybe I said we were going to end off with the general reaction of metals with oxygen, but I think I'll just maybe start there. What I mentioned at the beginning of the session was that air, okay, contains many elements. Obviously, they are in gas form, okay, and it contains three, okay, well, two main ones: nitrogen, oxygen, okay, carbon dioxide, okay, well, 2, 3 that are mentioned, and then of course there is other gases. Okay, so in the air we have 78% nitrogen, we have about 21% oxygen, and I knew something was wrong there. There we go. Oxygen. We have about a very small percentage of carbon dioxide, about 0.0375% carbon dioxide, which I'm just going to write as CO2, and then there is other gases. All right, so if we add this up quickly, we get to about 99,0375 percent of the air's a mixture. Okay, and then in some textbooks it will say that other gases are 1%. Okay, other textbooks will erase this statistic and go 78% and 21%, so 78% nitrogen, 21% oxygen, and other gases will be about 1%. Okay, because if you take 100 and you minus this, you get 0,9625, which equates to about 1 anyway. So usually they just leave out the statistic, but other gases makes up a very small amount of the percentage anyway. But your main drivers of your contents of air is obviously nitrogen and of course oxygen, and this plays a very important role obviously in our existence. All right, and oxygen, we know the importance of oxygen for our bodies. Okay, but that's just a quick little background as to what exists in the air. Let me go back there quickly. So now when it comes to metals, okay, when some metals burn in air, they react with oxygen. Okay, so let's maybe just add that down on our next layer here. Okay, that when metals burn in air, so when we see metals burning, all right, they actually have reacted with oxygen. Okay, there's actually been a reaction that takes place. Now we have looked at chemical reactions, we've looked at balancing equations, and those chemical equations are basically in equation form stating the reaction that's actually happening. So they actually can be also labeled reaction equations, all right, because they are showing or showcasing a reaction that has taken place within the world of chemistry. Okay, now metal has chemical properties as well as the air has chemical properties, as we can see. So when anything burns or set alight or is set alight in air necessarily, it's not reacting with nitrogen, but it's reacting with the oxygen. Okay, so the process of burning, okay, this process is called combustion. Combustion, okay? Key word in there is bust. Okay, when something bursts or busts, all right, there's a bit of an explosion. Okay, so I always teach my students this in colloquial language, that when anything reacts in oxygen, kaboom, fire, sets alight, explosion. I've been telling my students the story now for the past 5 years, and that there's a story that my teacher used to tell us as a class. I was at school of when he knew of someone who was struggling to light a fire in normal air, struggling to get his fire going. Maybe it was a bit windy, or the conditions just weren't very ideal, but he had an oxygen tank in his pure O2 oxygen in his garage. And so what he did was he opened up the oxygen tank on the fire, and long story short, he made it out by the hair on his back. In other words, he was very lucky to be alive. Okay, very dangerous just to open up pure oxygen on a fire. It's extremely dangerous because oxygen is highly reactive, and of course you're going to get a combustion reaction. But that process, the one name that we call is combustion, and that is when any substance reacts with oxygen, but mainly when metals react with oxygen. It is also called combustion. Okay, to carry on, when metals react with oxygen, okay, so if I get a metal of any type and I react it with oxygen, okay, the product that is formed is called a metal oxide. Okay, we touched and we've seen already metal oxides when we were balancing equations previously. So kind of everything is leading into one another, and we're connecting the dots as well as puzzle pieces. Okay, and of course that is also known as the general equation for these types of combustion reactions. So this is highly important. Okay, this one over here, as this is of course the general equation format for how metals react with oxygen. Okay. Alright, so the first metal we're going to have a look at is reaction of iron with oxygen. Okay, now when iron is burnt in air, it reacts with oxygen to form iron oxide. So if I write the word form, iron plus oxygen, obviously I'm going to get iron oxide. Okay, now let's check if we now write this in chemical form. Okay, so therefore, this you would never write therefore. I'm just writing therefore because it's a follow-on of this. I've got iron, I got Fe plus oxygen, which is O2. Okay, and what I get, all right, formed is iron is a transition metal. Okay, it's important to know that. Otherwise, it's very unstable. It bonds how it chooses to bond. It chooses how many bonds it wants to make at certain time. So often you'll see iron with a Roman numeral 2. This is two I's, capital I's, put together to make the Roman numeral 2. I'm sure you're all familiar with Roman numerals. Usually Roman numerals are written in small letters, but when it comes to chemistry, they're written in caps. And so this one is the iron 2, but in this equation I'm going to make it iron 3. That's a very bad iron. Okay, the iron 3 element. Okay, so it forms Fe2O3. In other words, the 2 from the oxygen went to the iron, and the 3 from the iron went to the oxygen. So I've got 2 irons bonded to 3 oxygens, or 3 oxygens bonded onto 2 irons. Okay.
Is that called magnetite?
Is that called?
Magnetite.
Magnetite.
The common name.
Magnetite. The common name for iron oxide. I'm not sure if I shared that name last week or something. I can double check for you. So that common name that you're talking about is this one. I just got to spell it right. Magnemite. There we go. It's a common name. I'll put that in there for everybody. It has many other names as well. You're welcome to do a quick Google search and then you'll find out its other common names that it is known by as well. Of course, about this equation quickly, if we just have a look at it, if you just block it off for just a second from all other information. Okay, what do you notice about this equation? Anybody would like to take a little guess?
It's not balanced.
Oh, excellent. Good observation there. Some Hawkeyes. Alright, it's not balanced. Okay, so of course we need to get into the habit of always balancing our equations. So let's go balance it quickly. Okay, we should remember this one from last week. What I'm going to do is, because I've got very low numbers on my left and quite high numbers on my right, so I'm just going to double everything here with a 2. And I'm going to put a 4 in front of the irons, and then I'm going to put a 3 in front of the oxygens. You're welcome to check, and let's count. So 2 in front of Fe2O3 gives me 4 irons and 6 oxygens all together here. So 4 irons, so I only have a single one here, so I'll put 4 there, and 6 oxygens, I only had 2 of them, so I'll put a 3 there to get them to 6 as well. So everything is balanced on left and right. Okay, that's now a balanced equation. Alright, a perfect way to end off the reaction of iron with oxygen. Now similarly with magnesium and iron is that magnesium, the metal form, magnesium is also, when it's burnt in air, it reacts with oxygen and it forms the product magnesium oxide. So if we have a look at that word equation again, we're going to have the magnesium that is reacting with oxygen to form, of course, magnesium oxide. Okay, so let's have a look in chemical form how that's going to look. I'm going to have Mg, which is magnesium on my periodic table, plus O2, and that's going to give me MgO. One oxygen is going to bond to one magnesium. Excuse me, I had a bit of a sneeze there. Alright, so it's simple. We react in it. MgO, perfect. Okay, only thing we must look at here is that the exception is, although oxygen makes 2 and magnesium makes 1 bond only, when these two come together, only one oxygen bonds to the magnesium and not 2. Okay, only one. This is what we call an exception. Okay, now again, this equation is also not balanced, so we need to go in and balance it quickly. The first thing that we notice is, of course, unbalanced is our oxygen, because our magnesiums currently are balanced, even though the entire equation is unbalanced. So if we insert 2 over here in front of the MgO, we know we have now 2 oxygens and 2 oxygens, but now we have doubled our magnesiums, and we need to insert a 2 in front of Mg on the left. Now we've got 2 oxygens, 2 oxygens, 2 magnesiums, 2 magnesiums. Our equation is obviously now balanced. Okay. So what we've gone through now, we've gone through metals, the general equation of metals reacting with oxygen. We've looked at 2 metals and how they react with oxygen. And we noticed that any metal plus oxygen gives us the metal's name, so either iron or magnesium, and the last word is oxide. Okay, and it works for both iron and magnesium. Okay, what we're going to do now is we're going to move into the sphere of looking at how rust forms, alright, and how it attacks metal, and it eats away, alright, it eats away at metal, and ways that we can also prevent rust, and that will end off this topic of reactions of metals with oxygen. So let's boost forward. Okay, this is all for this slide. Alright, so we're on to the formation of rust. Now, rust, as I've mentioned before, is basically it basically attacks metals. Right? It eats it, destroys it. Okay. But a metal such as iron, okay, iron reacts very slowly with oxygen. It doesn't happen quickly. Okay, acts very slowly. And that's why you will notice that a iron gate, if you take an iron gate, or if you take a any piece of iron metal that is not prevented against rust, you'll notice that over time, when I say time, a significant amount of time needs to take place or needs to go by for you to see rust forming or rust appearing, okay, as it eats away at the metal, okay. But it reacts slowly with oxygen at room temperature, okay. But if we want the process to increase, okay, we just increase the temperature. All right. So it reacts slowly with oxygen, and it's very important to denote that this is at room temperature. Okay, normal temperature basically, at room temp. But it's quicker as we increase the temperature. We'll write it as temp is increased. Okay, there we go. So, when iron reacts slowly with oxygen in the air, and also it reacts with water as well, because there's oxygen also present in water, okay, it forms a complex compound, all right, part of which is now iron oxide. Okay, we'll notice that this complex compound that forms, okay, this complex compound, okay, it has a reddish color to it. Okay, a reddish color. Okay, that reddish color or reddish brown color that we see also appearing on the metal, okay, this is what is known as rust. Okay, that is rust. Okay, we also know from the subject, as well as probably a bit of geography or technology, that rust is a form of corrosion, right? Which also is a term at substances being eaten away or destroyed. Okay, so just a side note quickly about what corrosion is. Corrosion is the reaction of the surface of a substance, such as a metal, with air, and usually to form a certain oxide. Okay, metals do corrode faster if they are wet, or if the air contains something called acid pollutants, which is known as sulfur dioxide. Okay, so that's a good little point to mention there, is that metals, they corrode. In other words, they get eaten away or they rust quicker or faster in water. Okay, so you can imagine any type of metal structure that is built underwater needs to be heavily protected against corrosion with other substances. Okay, they corrode faster in water, and or if the air contains pollutants. Okay, which is a very key word there, pollutants. An example of that pollutant, of those, or a type of pollutant rather, is sulfur dioxide, which is very acidic. Okay. Now, rust will form on the surface of iron when it is exposed to air and moisture. Okay, if it is exposed to air and moisture, and often on a hot day there's a lot of moisture in the air, they say the air is humid, there's lots of moisture in the air, and if your metal gates, burglar bars, anything metal or metallic that is exposed to air and moisture, also such thing as rain, okay, and if it's not protected against moisture as well as air, then rust will start to form, and over time you will see that the metal actually becomes weaker. All right, it becomes weaker. All right, so rust is a different kind of oxide of iron. Okay, and we say that rust is an oxide of iron that is hydrated. All right, do we all know what the word hydrated means? Hydrated basically means it's chemically combined with water. Okay, so rust is obviously combines chemically with water to eat away at metals. Okay, it's very bad. It's every person's nightmare that loves metal, and every person's nightmare who's a homeowner and didn't protect his gates or his burglar bars or anything metallic from getting wet or just being exposed to air. It's very annoying for them. My dad was an engineer, so he would often go and protect his work from rust, but I'm going to mention that a little bit later on inside this last 20 minutes that I have left with you guys. But just to make something known, also, Caitlin, can you just maybe take a screenshot of this in the meantime while I'm talking so I can change? Steel. Everybody's familiar with steel. Okay, we see steel everywhere we go, in most of the structures, the building structures, or infrastructure that we encounter on a daily basis. Okay, steel is quite essential in many modern constructions. Okay, it's quite an essential material. Okay, it's strong, it's hard, and it can obviously provide lots of stability to our infrastructure and construction. Okay, but steel is used more than other metals because it is strong and relatively cheap. Okay, so steel is actually a combination of more than one metal, just so by the way. But however, steel rusts and corrodes easily because it consists mostly of iron. Okay, so steel, combination of metals, but it rusts quite easy because most of its contents, or most of what it consists of, is obviously iron. Okay, and rust can seriously damage and weaken steel structures and iron structures, as well as equipment, if it is not if your steel or iron is not well prevented or coated or equipped to withstand this natural process, which is called rust. Okay, so we're going to look at ways that we can prevent our metals from rusting. Okay, there are quite a few ways. Okay, we're not gonna mention or write down all, but I'm going to mention as many as I can. But I'm going to introduce it with the story that I mentioned a little bit earlier. Now is that my dad was an engineer, so I would often go with him on these engineering trips just to see where he was going and what he was doing. And I always admired my dad's work, but he would always go and galvanize, okay, which is actually mentioned in the notes that I'm about to give you. Galvanize his metal gates, so he used to make a lot of gates, motorized gates, gates that would open up for front doors for people, for factories. He basically worked a lot with steel and iron, and he would always galvanize work or that he did, especially if he knew that the material or the steel structure that he had built was going to stand outside, or if it was going to be exposed to air or water, just to safeguard and obviously prevent these work from rusting, or the client wouldn't have to have that problem. Okay, even the gates that is on my house were made by him, and it is galvanized. We didn't even paint them, we just left them the galvanizing color, and we actually have no issues and no worries with our gates rusting, because they're not going to. They've been galvanized for years, more than, let me see, it's more than 10 years, almost 20 years. So galvanizing is very, very effective. So to get the ball rolling, okay, one of the first ways that we can prevent, okay, rust, right? Prevent rust or preventing rust. Okay, one of those ways, of course, is paint. Okay, paint the surface of iron or steel structures. Okay, and the type of paint that we want to use is oil-based paint. Okay, because this protects it from air and moisture. Okay, so this is one of the preventative measures we can use to, of course, safeguard our steel and iron structures. However, the layer of paint can scratch easily. Okay, if the paint is scratched off, even a little scratch, that is enough. The loophole is enough for air and moisture to still creep in and start rusting. Even if it's small, over time, remember, over time, it can cause bigger damages. Okay, so if it is scraped off, the iron or steel will be exposed to air and moisture, and when this happens, okay, iron will start to rust, and the paint will peel off. Okay, so when it comes to painting, you'll often see that painters paint more than one coat, and that's to prevent scratches from happening, because if a scratch does happen, at least there's another layer of paint, 3 layers or 4 layers of paint there, so that, you know, could just help better safeguard, of course, the iron structure or steel structure. Okay, but iron and steel can also be coated with a thin layer of metal, right, of another type or substance. Okay, it can be coated with a thin layer of metal that does not corrode. Okay, and that process we can call electrolysis, or electroplating. Okay, and electroplating or electrolysis, they make use of metals such as chromium or zinc. So chromium or zinc, they do not corrode. Okay, so they are used to coat iron and steel structures, so that when they are dipped out of this liquid metal, they can withstand rust, and in fact never rust at all. Okay, so we can use a form of electrolysis, okay, to put a thin layer of chromium or zinc onto iron or steel. Okay, and that process is called electroplating. Okay, so it's either called, you can call it electrolysis, or you can use the main, more specific name, which is called electroplating. Okay, but what electrolysis is, just to get the definition down here of what it is the breaking down, all right, of chemical substances. Okay, so we break down the chemical substances, there we go, by passing, and I'm sure you guessed this already, an electric current through a solution of them. Okay, so chromium and zinc, they are in solution form. They're not in metal. Well, they are always a metal, but they're in like liquid metal. Okay, because they are coated like paint almost. So I would imagine they're not taking a paintbrush is not really taking it, but they are rather dipped into a little tub of it and then pulled out again. And they are then coated, of course, with this little thin layer of shiny metal that is over them. And that is obviously also to prevent and stop them from rusting, and also lengthen their time of use. Okay, so if you do this, if you coat your metal, your iron or your steel structures, or whatever you have created with zinc or chromium, you lengthen the use that you'll have out of this particular item, whether it's a gate, burglar bar, or any type of steel structure. Okay, so when we use electroplating to coat iron with zinc, for example, it will take up the oxygen and form a zinc oxide, because it is more reactive. It's more of a reactive metal than iron. Okay, but I want to get to iron that is coated with zinc is called galvanizing. Okay, so I just want to add that here, and that is the third one, which is galvanizing. Okay, galvanizing is basically iron coated with zinc. So it's a type of electroplating, galvanizing, but we just call it galvanize, that the substance has been galvanized, or it is now galvanized iron. Once it comes out of being coated with zinc, it's now called galvanized iron. It is often used on roofs, and to make equipment such as shovels and wheelbarrows. Okay, those need to be very, very safeguarded against rust, of course, because those are heavy-duty tools. Shovels used to dig a lot. Wheelbarrows used to cart a lot of other substances. So yeah, we actually and spades, of course. Spade and shovel are two different things. So we've got old spades in the garage, and you can see they've existed for donkeys here. So rust has definitely got to them, like now in the latter years, but they were coated with zinc and before, and that I could still use them. They still work effectively. They don't break, but we can definitely see that rust has started to get to them now, but they are still quite strong, as rust takes a long time for it to do its job. So to maybe summarize this, we're going to put together a table that describes some examples of electroplating that is used to prevent iron and steel structures from rusting. And it's a very short table. It's only got four things in there, and this table is a great way for summarizing everything that we have just looked at. So I'll just draw it quickly. So what we have here is that table of 4 metals. Steel appearing 3 times, the electroplated metal, the metal that's used in the safeguarding process of preventing rust for the metals that's in the first group, and then of course some uses. So if you look at nickel, which is a metal that is used in creating cutlery, we electroplate that metal with silver, so we prevent our cutlery and jewelry from rusting, the cutlery being knives, forks, and spoons. For For steel, we also use zinc, and we electroplate zinc or steel with zinc on roofs or tools such as shovels or wheelbarrows. We also can coat steel with chromium, and that will be found on motor cars, bicycles, as well as in motorbikes. And then, of course, we can also coat steel with tin, such in our metal cans. Any metal cans that we see is coated with tin. So canned food, canned sodas, Coca-Cola, and everything like that is all coated with tin to prevent them from rusting, and to definitely slow down the process, as well as totally prevent rust from attacking the metal. And that concludes my session for this week, grade 9s. Please stay tuned next week, where we will have a look at reactions of oxygen with non-metals. Look forward to seeing you all then.